The future of robotics is being shaped by a profound shift, a movement from mere automation to genuine interaction. At the heart of this revolution lies the pursuit of tactile sensing, the ability of robots to perceive and interpret the world through touch. Imagine machines that can feel the delicate petals of a flower or gauge the pressure needed to lift a fragile object. This is no longer the stuff of science fiction. It's about endowing machines with a sense that is fundamental to our understanding of the physical world. Touch allows us to navigate, manipulate, and interact with our surroundings in a way that vision alone cannot replicate. By giving robots this sense, we are not anthropomorphizing them. Imagine robots that can assist in delicate surgeries, work alongside humans in factories, and provide care for the elderly with a gentle touch. The journey toward feeling machines has begun, and it promises to reshape our world in ways we are only beginning to imagine. To understand the significance of touch in robotics, we must first appreciate its profound role in our own lives. As humans, we are tactile beings. From the moment we are born, touch is our primary means of interacting with the world. A baby's first instinct is to grasp its mother's finger, a simple act that speaks volumes about the power of touch. Touch is not merely a physical sensation, it is deeply intertwined with our emotions, our sense of self, and our understanding of the world. A warm embrace conveys comfort and security. Our skin, our largest organ, is a complex network of sensors, constantly collecting information about our surroundings. The human sense of touch is a marvel of evolution, a symphony of biological senses and neural pathways that has allowed our species to thrive. Creating artificial touch systems that can rival the sensitivity and sophistication of human skin is a formidable challenge that has captivated engineers and scientists for decades. One promising avenue of research focuses on the development of electronic skin or e-skin. These flexible, sensor-embedded materials mimic the properties of human skin, allowing robots to detect and respond to a range of tactile stimuli. Imagine a robot with e-skin gently handling delicate objects, its movements guided by the subtle feedback from its artificial fingertips. Pressure-sensitive materials are another area of active exploration. These materials change their electrical resistance when touched, providing robots with a means of gauging pressure and force with remarkable accuracy. Taking inspiration from the human nervous system itself, researchers are also developing neuromorphic sensors. These sensors process tactile data in a manner similar to our own brains, enabling faster and more nuanced responses to touch. As these technologies continue to mature, we can anticipate a future where robots interact with the world with a level of sensitivity and skill that was once unimaginable. The integration of tactile sensing into robotic systems heralds a new era of human-robot interaction, one where machines can work alongside us with enhanced safety, adaptability, and precision. In the realm of healthcare, touch-sensitive robots hold the potential to revolutionize patient care. Imagine surgical robots with the dexterity to perform delicate procedures with minimal invasiveness, guided by the subtle feedback of their artificial hands. These robots could reduce the risk of human error, improve surgical outcomes, and expand access to quality healthcare. Beyond the operating room, touch-enabled robots could assist elderly or disabled individuals with daily tasks, providing physical therapy and companionship with a gentle touch. Manufacturing is another sector poised for a tactile revolution. Robots with a sense of touch could handle delicate components, perform intricate assembly tasks, and adapt to variations in materials with ease. The transformative potential of touch-enabled robots is not merely a futuristic vision. Real-world examples are already emerging, showcasing the remarkable capabilities of these machines and their potential to address real-world challenges. TouchLab's Velki robot, currently being piloted at Laxo Hospital in Finland, embodies the power of touch to enhance patient care. Equipped with eSkin, Velki allows remote clinicians to feel what the robot feels. enabling tasks like serving meals, adjusting assistive devices, and even brushing a patient's hair with a human-like touch. Another pioneering example is Robert, a gentle giant designed to assist with the physically demanding task of lifting and transferring patients. These early pioneers in the field of touch-enabled robotics offer a glimpse into a future where machines seamlessly integrate into our lives, providing assistance, care, and companionship with a level of sensitivity and understanding that was once unimaginable. The ripple effects of touch-sensitive robots extend far beyond the immediate applications in healthcare and manufacturing. In the realm of personal assistance, imagine robots that can not only perform household chores but also provide companionship and emotional support. The development of advanced haptic feedback systems allowing robots to transmit tactile sensations back to human operators opens up a world of possibilities in remote operation and telepresence. Imagine surgeons performing complex procedures from afar, guided by the tactile feedback from their robotic counterparts, or engineers manipulating delicate equipment in hazardous environments with a sense of touch that transcends distance. As touch-sensitive robots become more sophisticated, they will inevitably raise ethical and societal questions that we must address as a society. Despite the remarkable progress in tactile sensing technology, several challenges remain before touch-enabled robots become commonplace. One significant hurdle is the durability of tactile sensors. These sensors must withstand prolonged use, exposure to harsh environments, and the wear and tear of repeated contact. Developing robust and reliable sensors that can operate flawlessly in real-world conditions is crucial for the widespread adoption of touch-enabled robots. Another area of active research is the efficient processing of tactile data. Advances in machine learning and artificial intelligence will play a critical role in unlocking the full potential of tactile sensing. Creating robots that can seamlessly combine information from multiple senses to build a comprehensive understanding of their environment would represent a major leap forward in artificial intelligence and robotics. As we stand on the cusp of a new era in robotics, one defined by the ability to feel and interact with the world through touch, we can only marvel at the possibilities that lie ahead. Imagine a future where robots work alongside us as partners and collaborators, their actions guided by a sense of touch that rivals our own. Imagine a world where robots assist surgeons with unprecedented precision, provide care for the elderly with a gentle touch, and help us explore the farthest reaches of space and the deepest depths of our oceans. The quest for tactile sensing is ultimately about more than just building better robots. It's about expanding the boundaries of what's possible, pushing the limits of our understanding, and creating a future where humans and machines coexist and collaborate in ways we can only begin to imagine. How do you think robots with a sense of touch could change your life? What tasks would you trust to a robot with human-like touch sensitivity? Share your thoughts in the comments below. If you're fascinated by the future of robotics, don't forget to like this video and subscribe to Beyond the Circuit for more exciting explorations of cutting-edge technology.